Sustainable logistics focuses on reducing the environmental impact of transportation, warehousing, and distribution while maintaining efficiency and service quality. It aims to lower carbon emissions, reduce waste, and optimize energy use across the supply chain. Organizations adopt green practices such as eco-friendly packaging, route optimization, and fuel-efficient fleets. The goal is to balance economic performance with environmental responsibility. As global regulations tighten, sustainable logistics becomes a strategic advantage, not just a compliance requirement. Sustainable logistics focuses on minimizing environmental impact while ensuring smooth, cost-effective transportation and distribution. It follows the triple bottom line: people, planet, and profit to create long-term responsible operations. The growing push for carbon neutrality, stricter regulations, and customer demand for green brands makes sustainability essential. Companies like IKEA demonstrate this by targeting 100% zero-emission deliveries using electric fleets and renewable energy distribution hubs. Overall, sustainable logistics strengthens compliance, brand trust, and long-term business viability. Green logistics is driven by rising fuel and energy costs, strict government emission regulations, and growing corporate ESG commitments. Consumers increasingly prefer products delivered through sustainable supply chains, pushing companies to adopt greener practices. Investors are also demanding stronger climate-related disclosures, making sustainability a business priority. Amazon demonstrates this through its Shipment Zero initiative, aiming for 50% net zero carbon shipments by 2030. The company invests in electric delivery fleets and solar-powered fulfillment centers to reduce environmental impact. Green transportation focuses on reducing emissions and operating costs through smarter logistics choices. Companies shift freight from road or air to rail and sea whenever possible, while route planning and load optimization help eliminate empty miles. Fuel efficiency improves through driver training, proper vehicle maintenance, and aerodynamic enhancements. Many firms also adopt electric, CNG, hybrid, or hydrogen-powered fleets to cut carbon impact. A strong example is Siemens, which used a multimodal mix of sea, rail, and road to move wind turbine components, reducing lead time by 25% and cost by 12%. Route optimization and network redesign focus on reducing distance, fuel use, and emissions by making logistics routes smarter and distribution hubs more efficient. AI and analytics help cut idle time, avoid congestion, and rebalance warehouse locations for a lower transport footprint. These strategies improve both cost savings and environmental performance. DHL's Green program is a strong example where global carbon accounting and route optimization tools transformed operations. As a result, DHL reduced logistics-related CO emissions by 37% between 2007 and 2020. Green fleet and last-mile delivery strategies focus on using cleaner transportation options like electric and hybrid vehicles to reduce urban emissions. Companies optimize city delivery by consolidating drop-off points, which cuts traffic congestion and fuel consumption. Innovative solutions such as cargo bikes and drones help manage short-distance e-commerce deliveries efficiently. These approaches make last-mile logistics both cost-effective and environmentally friendly. They also support corporate sustainability goals while improving customer service. Green warehouse design focuses on reducing environmental impact through solar energy, LED lighting, natural ventilation, and other energy-efficient systems. Facilities use electric forklifts, smart HVAC, and water recycling methods to minimize resource consumption. Waste segregation zones support recycling and composting for better waste management. These practices lower operating costs while improving sustainability performance. A strong example is Procter & Gamble's LEED Platinum warehouse in Hyderabad, which runs entirely on renewable energy. Sustainable packaging focuses on using recyclable or biodegradable materials while reducing overall packaging size and unnecessary fillers. Companies increasingly adopt reusable crates, pallets, and closed-loop systems to minimize waste across the supply chain. These practices not only cut costs but also reduce environmental impact and improve brand reputation. Effective packaging strategies also support circular economy goals by enabling reuse and recycling at scale. A strong example is H&M's shift to 100% recyclable garment packaging, which saved 1,500 tons of plastic annually. Warehouse energy monitoring focuses on using smart meters to track electricity consumption across different zones and identify inefficiencies. Motion sensor lighting helps reduce wastage in low-traffic areas by activating only when needed. Predictive maintenance tools monitor equipment health and prevent energy loss due to malfunctioning systems. These measures improve warehouse sustainability while lowering operating costs. Overall, they create a smarter, greener, and more efficient facility. Reverse logistics refers to the process of moving products back from customers to the manufacturer or seller for returns, recycling, refurbishing, or safe disposal. The main objectives include recovering value, reducing losses, meeting environmental regulations, and improving customer satisfaction. It also supports circular economy models by extending product life through repair or reuse. The typical flow begins with a customer return, followed by inspection and routing to repair, recycling, or disposal. Ultimately, reverse logistics helps organizations reduce waste while gaining operational and environmental benefits. Reverse logistics includes activities such as returns management, refurbishment, recycling, recalls, and asset recovery to recapture value and reduce waste. Companies handle everything from defective e-commerce returns to repairing electronics and recycling packaging materials. It also covers safety-related recalls and managing reusable assets like pallets or spare parts. These practices help cut costs, improve sustainability, and support circular economy goals. Dell's Return to Dell program is a strong example, achieving high material recovery and significant manufacturing savings. Reverse logistics is challenging because return volumes are unpredictable and can fluctuate sharply. The quality of returned items also varies, making inspection and sorting difficult. These processes increase handling and operational costs compared to forward logistics. Organizations often need separate return management systems to track, evaluate, and route returned products. Together, these issues make reverse logistics complex and resource-intensive to manage effectively. A circular economy shifts logistics from the traditional take-make-dispose model to one that continuously reuses and regenerates materials. Instead of discarding products, organizations focus on repair, refurbishing, recycling, and returning materials back into the value chain. This approach reduces waste, conserves resources, and lowers environmental impact. It also creates new efficiency opportunities across supply chains. Overall, the circular model promotes long-term sustainability by keeping products in use for as long as possible. Logistics plays a critical role in enabling the circular economy by managing the return, sorting, and redistribution of used products and materials. It supports closed-loop supply chains where items are collected, reprocessed, and reintroduced back into production. Efficient logistics networks help recover value through recycling, refurbishing, and material reuse. This requires strong coordination with suppliers and waste handling partners to ensure consistent quality of reprocessed inputs. Companies like Unilever demonstrate this by recycling a major share of post-consumer packaging through circular logistics partnerships. Circular logistics is enabled by strong reverse logistics systems that efficiently handle product returns and route them for reuse, recycling, or remanufacturing. Digital tools like QR codes and RFID help track product life cycles and ensure materials flow back into the system accurately. Partnerships with certified recyclers and remanufacturers strengthen the closed-loop process. Many companies also use incentive-based return programs to increase customer participation. HP's Planet Partners program showcases this by recovering over 1 billion cartridges and significantly reducing CO emissions. Key sustainability metrics help organizations track and improve their environmental performance in logistics. Carbon Footprint Co. measures total emissions with a global goal of net zero by 2050. Energy consumption per unit identifies areas to reduce power use, targeting a 10% year-on-year reduction. Waste diversion rate and water usage track resource efficiency, aiming for over 80% diversion and less than 5 liters of water per ton handled. Sustainable packaging percentage monitors eco-friendly material adoption with a benchmark of more than 70%, supporting circular and responsible logistics practices. Organizations use reporting frameworks to standardize measurement and communication of sustainability performance. Tata Steel, for example, follows the Global Reporting Initiative GRI, ISO 14001 for Environmental Management, Carbon Disclosure Project CDP, and Science-Based Targets SBTI. ESG reports and sustainability audits provide transparency on progress and areas for improvement. Tata Steel publishes GRI-based sustainability reports that include logistics CO metrics. Through these initiatives, the company has achieved a 35% reduction in freight-related emissions since 2016. Digital tools play a crucial role in tracking and improving sustainability in logistics. IoT devices monitor fuel consumption and energy usage in real time, enabling immediate efficiency improvements. Carbon calculators, such as those from the Smart Freight Center or SAP EHS, quantify emissions for reporting and target setting. Blockchain technology ensures transparent and tamper-proof tracking of carbon data across the supply chain. AI-driven dashboards consolidate data, providing actionable insights for continuous environmental performance improvement.